This video is going to be about the even problems on Lesson 4.1. Lesson 4.1 is about systems of equations. The first section in the homework, numbers 1 through 7 on the homework, was having to do to check a solution to see if it really is a solution of a system of equations. So the first one will be number 2 that I'm going to work. It says x minus y is equal to negative 4. And 2x plus 10y is equal to 4. And they want us to test negative 3, 1. For the ordered pair negative 3, 1 to be a solution, we have to be able to plug negative 3 in for x and 1 in for y, and it should make both equations true when we do. If only one equation is true and the other one is false, it's not a solution. So I'm going to test this one here. X is negative 3 minus y, which is 1. That is true that it equals negative 4. 2 times negative 3 plus 10 times 1 would be negative 6 plus 10, and that... Uh-oh. Guess my computer's getting tired. There we go. 10. And that is equal to 4. So since both of them are true, I can say that negative 3, 1 is a solution. Number 4 is the same type of problem, so I'll do the exact same thing. Of course, different equations, different numbers, but 2x minus 5y is equal to negative 2, and 3x plus 4y is equal to 4. The numbers I'm going to try in is 4 and 2. I'll plug them into the first equation to see if it makes it true. I'm going to put a question mark over the equals because I don't know if it's going to be true or not. 8 minus 10, that is equal to negative 2. So that one is true. Trying the other one. 3 times 4 plus 4 times 2. Looks like a lot of numbers here to equal 4. We'll put a question mark on it. 12 plus 8 is not equal to 4. So this one is false. And actually, this statement is true. If it had said equal, it would be false. But 4, 2 is not a solution. Now, all the methods we use for finding solutions, such as graphing and substitution and linear combination, or also called elimination in this book, that's all ways that you can actually find the solutions, but right now we're just testing to see if these ones they gave us were solutions, and that one is not. On all our other problems we do, if we wanted to plug it in like that after we got finished just to verify and make sure it was true, we most definitely could, but that's a lot of writing. Alright, number 6. Y equals 6. X equals negative 2. Y. And they want us to try out negative 12, 6. Okay, I'm going to start off by plugging 6 in for y here. 6 equals 6. That's definitely true. Plug in negative 12 and 6 for x and y here. Put a question mark on it because we're going to test it and see. Okay, negative 12 is equal to negative 12, so that is true, and we have a solution. For most ordered pairs, there usually is only one solution. So instead of saying a solution, I could even say is the solution. The way we tell if it has more than one solution is it has to be the same line to have more than one solution, or maybe not be linear. If it was a parabola or some other shape, a curve. It could curve back and hit more than once, but for linear equations, it will only have one solution, unless it's the same equation, same line. That was number 6. I believe this one over here is number 8, so I'll try to write it down. 4x plus 5y equals -7. Oh, fun, it's going to have a fraction. -8x is equal to 3y minus 1. Alright, these are not both standard form. This one is, but that one's not. Doesn't really matter when we're plugging these in to see if they're true. We just need an equation. 4 times 3/4 plus 5 times -2. We're trying to find out, does that equal -7? 4 times 3 is 12, divided by 4 is 3. Plus -10, that is equal to -7. So, it worked in the first equation. Let's try in the second equation now. -8 times 3/4. To be a solution, that will have to equal 3 times -2 minus 1. -8 times 3 is -24, divided by 4 is -6. We're trying to find out if that's equal to -6 minus 1. I don't think so. -7. And they are not equal, and because they're not equal, I could say 3/4 -2 is not a solution for that system of equations. Okay. Now what we'll do is on the next questions, they want us to use graphing to find the solution of these. Okay. Well, we know if we're graphing linear equations, we have to get them in slope-intercept form first, preferably. I think it's going to be better to write these side by side if we're going to try to graph them. That way we have room to rewrite them. I'm going to solve for y on both sides eventually. This is not inequality since I don't have to reverse the sign. I guess if you reverse an equal, you'd still have the same thing. Negative divided by negative is positive 2x, and positive divided by negative is -8. So there's my first equation. Here's my other one. Got a minus x. Divided by 3. And this will be interesting. Alright. -8. 1, 2, 3, 4, 5, 6, 7, 8. Now a piece of graph paper would have made this better. Y-intercept was -8. Slope is 2. So for every time I go over 1, I'm going to go up 2. I'm going to project this on out a little ways. Just because if I don't, I won't really be able to tell where the two lines hit. Okay, here's my first line. And the other one, 11/3. That is 3 2/3. So should be here. Slope is -1/3, so when I move over 1, I'm going to drop a third. It'd be easier if I project it out though, down 1/3. And it looks like the solution is going to be at At a place it's hard to tell. Looks like the solution is right here. To me, it looks like 5, 2 possibly. Now, how could I know if that's really the solution? Well, just like we did before, if I take the 5 and 2 and plug in here, 5 right here, if I put a 2 right here, that makes 6. 6 plus 5 is 11. 5 times 2 is 10. Take away 2 is 8. So 5, 2 is a solution, and graphing did work out as a method of doing it, even though it's usually not the most dependable.